Today we start working with one of the most important rules about differentiation, which remember just means finding the derivative, and that is the chain rule. Okay? And what we have to really think about here is this idea of a composition of functions. I told you that for the time being, we only knew how to find the derivative of, let's say that I had the sine of x. That was all we knew how to do, was just find the derivative of sine of x. And we said, of course, f prime was cosine. But I told you that we would have to learn later on how to find the derivative of I'll write in a different color. The sine of 3x plus 7. Okay? And that is a composition of functions. Do you remember what a composition of function is? That's when we have something like f of g of x. Okay, we have one function. We have one function plugged into another function, all right? And so let's look at this little sine of 3x plus 7. What function was plugged into sine? 3x plus 7. This little thing right here would be my g of x. I often like to refer to that as my inner function, or inside function. So what was the original function? Sine of x, okay? F of x was originally sine of x. Okay? So if I were to look at f of g of x, in this case, based on these two definitions, that g of x was 3x plus 7 and f of x was sine of x, then I would wind up with what I had up there, the sine of 3x plus 7. Okay? Now I went through all of that for a very important reason. Because the chain rule is defined and works completely based off of the composition of functions. So if I were to call a specific function h of x, and that particular h of x was a composition of functions, okay? Then we wind up with this chain rule. And I'm going to put this on, I'm going to put this up here. Chain rule, and I'm going to call this method 1. And you'll find out why I'm calling it method 1 later. All right? So, if I am given a composition of functions h of x equal to f of g of x. Okay? If my situation, if the thing I'm wanting to find the derivative of is a composition of functions, okay, then h prime of x, okay, or the derivative of that composition of functions is going to be f prime of g of x times g prime of x. All right? And that right there is the chain rule for the composition of functions, which we must follow. Now, what I want you to notice a little bit, I will use some words a lot of times like outside function and inside function. Let's go back to our first page, if my Mimeo will cooperate. Which one of these two did I say was the inside function? Okay, I said that this one right here was the inside function, right? And we call the inside function g of x, all right? And we call the outside function f of x. This is the outer, all right? So if we look at the chain rule, let's kind of talk our way through this a little bit. This chain rule is saying I'm going to find the derivative of the outside, right? I'm going to find the derivative of the outside and then plug in g, okay? Plug in. And then I'm going to multiply that by the derivative of the inside. Okay? So, let's look at my original example. I'm going to try to squeeze it in on this page right here. If my h of x is the sine of 3x plus 4. Well, let's identify my two functions. You don't always have to do this, but at the beginning, yeah, I guess it was 3x plus 7, wasn't it? I can always count on my faithful AP Calculus students to find any error that I ever make. So that's the sine of 3x plus 7. First off, what is the outside f of x? What is it? Isn't it just the sine of x? Right? That's the f of x. The g of x is the 3x plus 7. Okay? So, following the chain rule says, and we need to learn it, so let's write it. And I want you to write it as you use it. H prime of x equals f prime of g of x times g prime of x. That little thing right there is your roadmap. Okay? So it's going to lead you to success, so use it. So, let's use this now. What is the derivative of f? Cosine. Now look though, look at my formula. It is cosine of what? 3x plus 7. All right. Times, what is the derivative of g of x? 3. Problem's done. We usually would put the 3 in front though. 3 cosine of 3x plus 7. And that would be h prime of x, or it's just the derivative of, whatever letter you want to use. It's the derivative of that function. Okay? So, there you have it. It's not that bad. Let's look at another one. We'll call that one example 1. What if h of x is equal to the square root of 5x cubed plus 3x squared? Now, remember what I told you. You have to be able to recognize when to use the chain rule. Do you see that this is much different than just the plain old square root of x? Right? Because look, I've got an inner mess and an outer mess. Okay? I think it's always easier to find the inner mess first. So let's identify those. What is my inner mess? What is my g of x? Very good. 5x cubed plus 3x squared. So that means my outer function is just the square root of x. All right? So let's write the chain rule. H prime of x equals f prime of g of x times g prime of x. Okay? So we're going to just take this thing one piece at a time. First, f prime. Well, right here is my function, the square root of x. So maybe we need to come over to Rivendell for a second. F of x equals x to the 1/2, doesn't it? So f prime of x is going to be 1/2 x to the negative 1/2, using the power rule. Now, that is f prime of x, but my chain rule says it's supposed to be f prime of g of x. So this is going to be 1/2, and I'm going to put g in right here. So this is going to be 1/2 times 5x cubed plus 3x squared, that whole thing to the negative 1/2 power. F prime g of x. Times just the derivative of g prime. Just the derivative of this. That should be pretty easy. I'm going to put it in parentheses. 15 x squared plus 6x. Okay? Now, that is somewhat ugly, and like I mentioned to you before, the final form of these derivatives is often up to some opinion, but I think we could clean this up a little. Notice what I've got here. I have a negative 1/2 power. Isn't that a square root that's in the denominator? So really what I have here is I've got the square root of 5x cubed plus 3x squared in the denominator. And I've also got a 2 down there as well because of this 1/2. And then on top, I can just have this part, 15x squared plus 6x. And even though that's a fraction, I think that is a better form than what we had before. So I would call this my final answer for h prime of x, the derivative. Don't forget everything we've learned, that derivative is the general slope function. Tells me the slopes of the tangent line. Right now we're learning a lot of skills. I don't want you to forget the graphical meaning. How about this problem? I guess this is going to be h of x. H of x equals 5x minus 4 quantity squared. Now you've seen some of these, and I told you for the time being go ahead and FOIL them out, but this can also be done with the chain rule. All right? So if we do it with the chain rule, my g of x is 5x minus 4. My f of x, my outer function, is what? X squared. Okay? So following the chain rule, h prime of x equals f prime of g of x times g prime of x. This one's a little bit easier. What is the derivative of the outside? It's just going to be 2x. So this is going to be 2, but it is f prime of g of x. So it's going to be 2 times 5x minus 4 times, what is the derivative of that? 5. Problem's basically done. 10 times 5x minus 4. After you do enough of these, I think you're eventually going to see the way that I kind of concluded the chain rule works. It's the derivative of the outside times the derivative of the inside. The derivative of the outside times the derivative of the inside. Okay? But you just have to remember that you have to put that function in. When I say the derivative of the outside, it's the derivative of the outside with g of x plugged in. Okay? So you're basically looking at two pieces, inner and outer. Let's do another one. No, I think that one's good enough the way it is. What if h of x equaled 2x plus 1 over 4 minus 3x, the quantity cubed. Okay, there's an ugly one. Well, right off the bat, you should notice a couple things. I do have an inner function, but that inner function is a quotient, right? So you got to keep that in the back of your mind. We're going to have to use that in a minute. So my inner function, g of x, is what? What is my inner function? 2x plus 1 over 4 minus 3x, that ugly thing right there. And then my outer function, f of x, is x cubed. All right? So let's write our derivative, h prime of x, our chain rule, f prime of g of x times g prime of x. Okay? So the derivative of the outer function, that's easy, 3x squared, right? So that's going to be 3 times the mess squared. Well, in this case, the mess, it's always going to be g of x. It's that ugly fraction up there, that rational function, 2x plus 1 over 4 minus 3x. Times, oh boy, quotient rule. Now, how do I do this? If I was a math student, how would I write this on my piece of paper? Well, I guess you could put a big bracket right here and do all your work. Or you could go to Rivendell and go over to another land and do it. So it doesn't matter. Do you want to go to Rivendell?
Yeah.
Let's go to Rivendell. The quotient rule says that I'm going to do the derivative of the top, which is 2, times the bottom the way it is, minus the derivative of the bottom, which is negative 3, times the top the way it is, all over the bottom squared. So this little numerator is going to become 8 minus 6x, and this is a positive 3 here, positive 3. So that will become plus 6x plus 3. So it looks like the 6x's go away. Get out the slasher. And I just have 11 over the quantity 4 minus 3x squared. And that is what goes in my bracket. I wouldn't FOIL it out, no. I'm going to put that over here with the matching pretty blue color. 11, this thing's coming up here. 4 minus 3x quantity squared. That was my derivative of g. Now, we need to clean up that answer a little bit. Do you see that I have a 4 minus 3x in both denominators? Look right here. And isn't this one going to be raised to the second power? Right? So technically what I have right now, I'm going to go to a new page, is right now I have 3, right now I've got this. I'm just recopying it. Okay, I'm just trying to help you get to a cleaner final answer. Well, if I distribute this second power to the numerator and denominator, then I have 2x plus 1 quantity squared over 4 minus 3x quantity squared. I still have this times 3, and I still have this thing over here. And now maybe the light bulb will come on with that 4 minus 3x. Do you see that I basically have 4 minus 3x to the 4th? And the bottom to the 4th? And then I have, it looks like a 33 times 2x plus 1, the quantity squared. And that is about as clean as we can get that derivative. And we are going to stop there for today.